Hello everyone. In this video, let us see Universal Law of Gravitation. Newton proposed the Universal Law of Gravitation, which gives us the mathematical expression for the gravitational force. The Universal Law of Gravitation states that the magnitude of the force with which two bodies attract each other is, let's see statement 1, directly proportional to the product of the masses. And B statement is inversely proportional to the square of the distance between them. So, the definition of universal law of gravitation has two parts. The magnitude of force with which two bodies attract each other is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. Let M1 and M2, let us consider this is M1 and this is M2, be the masses of the two bodies and d be the distance between their centers. The center of this body to the center of this body, the distance let us consider as d. So according to universal law of gravitation, we can write the force of attraction, the magnitude of force of attraction is directly proportional to the product of the masses. Here mass is m1 and the other mass is m2. Let us consider this as expression 1. And the second part of the definition is this force is inversely proportional to square of the distance between them, 1 upon d square, as we have considered the distance between the centers of two bodies is nothing but here d. Let us consider this as expression 2. Combining 1 and 2, we can write from expression 1 and 2, we get F is proportional to M1 M2 upon D square. So we can write this as F is equals to capital G into M1 M2 upon D square. Here G is where capital G, what it is, it's a proportionality constant called as, what it is called as universal gravitational constant. Universal gravitational constant. So let us define what is G. Okay, let M1 is equals to M2 is equals to 1 kilogram and the distance between their centers, let us take it as 1 meter. Then the expression can be written as F is equals to capital G into M1 is 1 kilogram and M2 is 1 kilogram upon distance is 1 meter, that is D square 1 square. So we can write this is equals to G into 1 upon 1. So that's nothing but G. Therefore, capital G is equals to F. The universal gravitational constant is the force of attraction between two bodies of unit masses separated by unit distance. Now let us see units of capital G. From the expression, we got just now the expression as F is equals to capital G M1 M2 upon D square. So from this, if we take capital G subject, then we can write this as F D square upon M1 M2. Okay. So the units of force in SI system are Newton. Okay. Units in SI system. Force is measured in newtons. Capital G is equals to force is in newtons. Distance, it is measured in meter square upon mass kilogram into kilogram, right? So we have M1 M2. So we can write this as Newton meter square upon kilogram square, and this can be represented as Newton meter square per negative power of 2. Let's see the numerical value for universal gravitational constant. Okay. In SI system, the numerical value of universal gravitational constant is, this was measured by experimentally Henry Cavendish. This value is given as 6.67 into 10 to the power minus 11 Newton meter square per kg square, right? The value in CGS system is, in CGS system, the numerical value of G is, what is G here? Universal gravitational constant. So in CGS system, units are dyne centimeter square per gram square. The relation between Newton and dyne is 1 Newton is equals to 10 power 5 dyne, and 1 meter square is equals to 10 to the power of 4 centimeter square, and 1 kilogram is equals to 10 to the power of 3 grams. So when we simplify it, then the value is 6.67 into 10 to the power minus 8 dyne centimeter per gram square. So this is the value of universal gravitational constant in CGS system. Let's see dimensional formula for G, right? Dimensional formula. Dimensional formula of universal gravitational constant, that is G. Let us see what could be the dimensional formula for G. We know dimensional formula for force. Force formula is mass into acceleration. Mass is kilograms and acceleration is meter per second square. So the dimensional formula for force can be written as M L T to the power minus 2. So this is the dimensional formula for force, and dimensional formula for distance is length, it is, right? The fundamental quantity is length. And dimensional formula for mass is, is m. So now we can write dimensional formula for universal gravitational constant G. So Fd square by m1 into m2, right? So here force dimensional formula is m L t to the power minus 2, and distance formula is d square, so we can write L square upon mass m1 into m2, so m to the power 2. So here m and m get cancelled from this, right? And L into L square will get L cube, and t to the power minus 2 remains same. So the dimensional formula for universal gravitational constant is m to the power minus 1, L to the power 3, t to the power minus 2. So this is the dimensional formula for universal gravitational constant. Why G is called universal gravitational constant? So to answer this question, let us, when we defined capital G, we have assumed that masses are 1 kilogram and distance between them is 1 meter, right? As masses are fixed, this is capital G is independent of mass of bodies, and the distance between them we have fixed it as 1 meter. That means capital G is independent of distance between two bodies, and even it is independent of the medium between the bodies. Along with mass and distance, it is also independent of the material with which the bodies are made up of. And anywhere in the universe we can consider two bodies. So all these reasons we have to say that capital G is universal gravitational constant, and the value of capital G remains same throughout the universe, right? So now let us consider an interesting example of the force of attraction between any two bodies. This law was proposed by Sir Isaac Newton. Let us consider an interesting application of F is equals to capital G m1 m2 by d square. So the question is, find the force with which you and your friend having the same mass of 40 kilograms and sitting on benches separated by 1 meter attract each other. Here we need to find the force of attraction between two friends. Their masses are 40 kilograms each, and they are separated by distance of 1 meter. Let me consider it's you and this is your friend, right? Both of you are 40 kilograms each, and you both are separated by a distance of 1 meter. Yes, right. So now let us see solution of this numerical. Let m1 and m2 be your masses respectively. So we can write this as, so m1 is equals to m2 is equals to 40 kilograms, right? And distance between them, distance between them, let us consider it as d, that is equals to 1 meter. So we can use that formula as F is equals to capital G m1 m2 divided by d square. And what is G value here? G is equals to 6.67 into 10 to the power minus 11 Newton meter square per kg square. So if we substitute these values, G value is 6.67 into 10 to the power minus 11 into mass is 40 kilogram M1 and M2 is 40 kilograms divided by D square is what is here? 1 whole square. When we simplify this, we can write this as 6.67 into 10 to the power minus 11 into 4 into 4, 16 into 100. So we can cancel this two zeros and in this two zeros, and divided by 1 square is 1, something by 1 is something. So we can write this as 6.67 into 16 into 10 to the power minus 9, right, newtons. If you multiply these two terms, we will get answer as 1.06 into 10 to the power minus 7 newtons. This is the force of attraction between two friends of masses 40 kilogram each, and when they are separated by a distance of 1 meter. Hope you have understood universal law of gravitation, its formula, its dimension formula, units, and the application. Thank you.